In this lesson, I'm going to explain you about network architecture. First of all, let's talk about transmission modes. What we mean by a transmission mode? Transmission mode means the way or the mechanism of transferring of data between two devices. This is also known as the communication modes. There are three different types of communication modes which are named as simplex, half duplex, and full duplex. In simplex communication mode, when a device transfers data signal to another device, the device that receives that data cannot transfer a signal back to the sender. This means in simplex communication, communication occurs in one direction only. For an example, if we consider television, radio, and all broadcast signals, all those broadcast signal transmissions happens one direction only. In half-duplex communication, the devices at both the ends can communicate with each other, but it happens only one direction at a time. For an example, if you have a conversation between two people using a walkie-talkie device, one person will always have to wait while the other person finishes saying his message. In the third transmission mode, communication happens simultaneously at the same time. This is known as full duplex communication. For an example, when you have a telephone conversation, both parties at the ends could speak at the same time. Whatever the type of transmission mode you are using, there must be a certain rhythm of transmitting signals. This rhythm of transmitting signal is known as transmission synchronization. There are two types of transmission synchronizations, which are known as asynchronous and synchronous. Asynchronous transmission means it is just similar to half-duplex transmission, which is slow and where the receiver usually gets the message after some delay. For an example, if you send an email as the sender, the receiver will usually receive that email after some delay. On the other hand, synchronous transmission is just similar to full duplex mode, which is more efficient, and the receiver usually gets the message directly when it is sent. For an example, when you have voice or phone communication, then both parties can communicate at the same time without having a delay. And now I'm moving on to a categorization of networks based on its architecture. When we talk about network architecture means the way that network hardware as well as network software are organized within a network. First of all, we are going to talk about client-server model. In client-server model, we talk about client computers as well as server computers. Server computer is a computer which provides services requested by the client, and a client computer is a computer that requests service of another computer system. For an example, when you are using email and World Wide Web, you receive information as a client, and this information are provided by different servers. Next, we move on to peer-to-peer architecture. In peer-to-peer computing, there is no separate server, and all the computers connected to the network have same rights. In a work group, there is a collection of computers within a local area network. You will learn what is this local area network in upcoming lessons. So if we have a work group, In a work group, there is a collection of computers, and all those computers share common resources as well as common responsibilities. And when we talk about this arrangement, this is not a physical arrangement, this is a logical grouping of computers which allows to share resources with each other. The next important term in this lesson is multiplexing. The purpose of multiplexing is to transmit signals more efficiently over a communication channel. Multiplexing is a process in which multiple signals are combined into one signal. When we consider about the different types of multiplexing, we find three types: space division multiplexing, frequency division multiplexing, as well as time division multiplexing. And now we have come to another category of networks. Here we talk about the physical arrangement of computers within a network. When we talk about client-server model, peer-to-peer model, and work group, there we talk about the logical arrangement of computers. But in this section, we talk about physical arrangement of computers. So this physical arrangement, we call it is as topology. For an example, bus network topology, star topology, ring topology, mesh topology, tree or hierarchical network topology, as well as hybrid network. When we consider bus topology, here each node is connected to a single cable. As you see in this picture, there's a single cable in the middle and all the other nodes are connected to that cable. And when we talk about star topology, the arrangement looks like a star, and in the middle we have a central device called hub or a switch, and all the other nodes are connected to that hub or switch using point-to-point connection. And here we have ring and mesh networks. When we talk about the ring network, it is arranged as a ring. It is arranged in a circular way to a single cable. In a mesh network, each node is connected to all the other nodes using multiple cables. So one device has multiple connections. Even if one connection lost, there are some other options to connect with other devices. And when we talk about the tree or hierarchical network, the hosts are arranged into hierarchical structure, and here the top level has only one node. And hybrid network means a combination of one or more network topologies we have already discussed above. And finally, we have come to the categorization of network based on its scope. Here we have 6 categories: GAN, which means Global Area Network; WAN, which means Wide Area Network; MAN, which means Metropolitan Area Network; CAN, which means Campus Area Network; LAN, which means Local Area Network; and finally PAN, that means Personal Area Network. So all these types are based on the scope of the area it covers. So GAN covers the whole world, and WAN covers countrywide area, and MAN covers citywide area, CAN covers multiple buildings with about 1 kilometer, and LAN covers a building within about 100 meters, and PAN covers a space of a room. So as you see in this picture, here in the middle we have local area network, and then local area network is a part of metropolitan area network, and those two, local area and metropolitan area networks, can be taken as parts of wide area network, and GAN is the biggest one, which covers the largest scope. When we forget about the personal area network, thereafter we have local area network, which we usually use. Why we go for a local area network is that we can have number of advantages of using local area network. We can share hardware, we can share software, and we can share our files using central servers. We can have a local area network for serving printers and as a automation support for offices, and we can use local area network for manufacturing support and so on. There are certain disadvantages of these networks as well. If you want to build a local area network, you will need additional equipments to connect your computers together, and in advance you will need to maintain the network. So you have to bear the cost of equipment as well as the cost of maintenance. And also, when we try to connect the devices we have in our organizations or in our institutes, there may be problems of interoperability. So therefore, we will have to figure out those problems as well. So with this, we have come to the end of this lesson. And in upcoming lesson, you will learn more about this network architectures.